Okay, 1.6, parent functions. Our library of parent functions is what we're looking at. All right, so our goal here is to be able to take some basic functions, x squared, x cubed, and just a regular straight line, right, linear function here, and know some basic things about them. All right, so here's our first checklist. This is for a linear function, so this is for a straight line, something like this that crosses, right, has a b down here, has a slope. This is y equals mx plus b, regular old straight line. All right, domain, everything. We can plug in any x we want, no problem. Which means also the range, we're going to get every y value because we're going to go up and down forever. Right? We have an x-intercept of negative b over m, comma 0, and a y-intercept of 0, comma b. This one we know all about. This one here might be a little bit new to us. Kind of handy once in a while if we want to know where we're crossing here, negative b over m. All right, and we're increasing if the slope is positive and decreasing if it's negative and constant if the slope is 0. Remember, vertical lines have an undefined slope. Okay? All right, so we can write a linear function here for 1, 3, 4, 0. Let's find our slope right away, and so plug in y values on top, x values on the bottom. We've got 3 over negative 3, which is negative 1. And we do have, we do not have an intercept yet, so we're going to have to use point slope. So y minus, pick a y number. 3 works just fine, equals negative 1, x minus 1. And let's move this around. Y minus 3 equals negative x plus 1. Add the 3. Y equals negative x plus 4. And there is our linear equation. All right? I think you can do this. Exercise 11. All right. If you're done with that, let's take a look at some of our other functions here. Before we move on, just a reminder, there's some special ones. F of x equals c. This would be like y equals 5. That's horizontal, right? It's going straight across. And then the special function y equals x is called our identity graph. Where's it written? There we go. Identity function. This one goes through the origin with a slope of 1, up 1 over 1. Okay? So we want to be able to do that. We use this a lot in reflecting things over the y equals x line. Okay, so something we know about, y equals x squared. So this is a parabola touching the origin, going like that. All right, so the domain, all real numbers. Range, only above 0, right? We don't go down at all below the x-axis. So the range has to be non-negatives, 0 and above. The function's even. Remember, that's y-axis symmetry. The graph has an intercept at 0, 0. The graph is decreasing from negative infinity to 0, and then it turns around and is increasing again. And it's symmetric with respect to the y-axis. Oh, we already said that. It's even. And it has a relative minimum there at the origin. Okay, just some basic things we need to know about the x squared function. We call this the squaring function. Makes sense. It's x squared. Okay, and the next one is our cubic function, and it looks like this. Okay, some important points here, 0, 0, which is where our intercept is. Some other important points here are 1, 1, and negative 1, negative 1. Okay, so the range is everything, the domain is everything. Up here, it's odd, which means we have symmetry with respect to the origin, and it's increasing everywhere. It's just going up and up and up and up. All right, how about the square root function? Looks like this. Starts at the origin, takes off like that, okay, and then flattens out. So origin increasing always. It looks like it kind of is flattening out here, but it's always going to be going up just a little bit higher and higher as we move on. Okay, domain is positive and range is positive only. We're only going to live in quadrant 1 for our square root function. Okay, and let's talk about 1 over x here. What does this look like? Okay, 1 over x. I gotta look this up myself. I've forgotten. Where'd you go? 1 over x. So embarrassing. Aha, that's right. It's this guy. Okay, 1 over x looks like that. So, a couple important things. We're getting closer and closer and closer to the y-axis and the x-axis, but we're never going to quite touch it. Okay, that makes it symmetric about the origin. We're decreasing as long as we're not touching 0, so we're always decreasing, right? We're always going down here, and we're always going down here. All right, no intercepts. It's never going to cross y or the x-axis. All right, and the range is everything except for 0. It's never going to touch 0. Okay, that's the only place it can't be, which makes sense because it's 1 over x, and remember we cannot ever divide by 0. All right, so now the two kind of new ones, step and piecewise functions. So the step feature probably totally new for you. And so let's take a look at what it means. It's this double bracket thing. The greatest integer less than or equal to x. So this is kind of a rounding thing. So what we're going to say is, okay, the step function of 5 is just 5. The step function of 5.1, still 5. All right, 5.9, still 5. But as soon as we jump up to 6, then it's back to 6. Okay, so it's just rounding. So when we graph it, okay, it looks like this. Sorry, I'm off by 1. It looks like this. Okay, as we jump out, so 0.1, 0.2, 0.3, 0.4, 0.5 all goes down to 0, and then as soon as we hit 1, we jump up here to y is 1. And then 1.1, 1.2, 1.3, 1.4, 1.5, as soon as we hit 2, then we jump up to 2. Okay, so it steps. It looks like a ladder as we jump up and up and up. All right, so evaluate the step function of this when x is 1, 2, and negative, or and 3 halves. All right, so just plugging things in. The step function of integers just cleans up as themselves. It's negative 1 plus 1, so that's just 0. What about if we plug in 2? Same thing. The step function of an integer is just itself, so 2 plus 1, 3. But now here comes the new thing, so we're going to evaluate a fraction. So 3 halves, that's 1.5. Okay, what's the biggest integer below that? If we're rounding down, it's going to turn into just 1 plus 1 is 2. Okay, so we're just rounding down until we hit the integer. All right, so try exercise 43. See if you can get it. All right, and then piecewise. We've talked about this a little bit. I want to make sure we can do this on our calculator here and see this. Let me bring up the calculator. And so our step function here is, go to our y equals 2x plus 3. And I'm going to put this in parentheses here because there's two different functions I'm worried about. 2x plus 3. And then I'm going to do a separate parentheses, and I'm going to talk about what the x could be. Okay, so I'm going to put restrictions in. X is less than or equal, so I'm going to go in here to test. Second test, less than or equal is number 6. So I'm just going to hit 6 to go straight to it. Less than or equal to 1. That's my y1. My y2 is negative x plus 4. And my restriction is x has got to be bigger than 1. Oops. Got to be bigger than 1, so that's number 3. All right, so what this is going to do is say as long as x is smaller than or equal to 1, we're going to draw this graph. But as soon as we hit x is 1, we're going to switch it over and go to this graph. So let me change up our window here again, negative 10 to 10. Go ahead and hit graph. And you can see exactly what's happening. We've got one graph going up, 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 and up until we hit x is 1. And then as soon as we hit x is 1, we draw a different graph. So all this is two different graphs drawn on the same coordinate plane. Okay? And so that's what we would sketch down on our paper as our answer. All right, so see if you can come up with the same thing for exercise 57. And I believe that's it. Yes, it is. So just at the end of the chapter here, and I've got them up here, are just the graphs of the different functions you're expected to know. The constant function, the identity, your quadratic, your squaring, your cubic, x cubed. And now one other one we didn't talk about in this chapter, but absolute value is a v. Square root we talked about. The reciprocal, 1 over x. And then our greatest integer, our step function, looking like this. All right, so have those down. Be ready to use them. Questions, please let me know.